We've all experienced this at least once before. We get up early and pour ourselves a hot cup of coffee to warm ourselves up for the day, only to be left with a tepid pool of bitter letdown within a few minutes. For most of us, we've come to accept this phenomenon as a simple reality of the world that we live in. But here at Infinite Limit, we saw this otherwise mundane process as a potential solution to one of the biggest problems affecting the developing world. All objects warmer than absolute zero are constantly radiating heat in all directions. This means that a warm object will begin to cool down to the temperature of its surroundings, as it is radiating more heat energy than it is receiving back from other objects around it. Conversely, this also explains why things tend to get warmer out in the sun. Despite emitting large amounts of energy themselves, the sun is radiating heat at a much faster rate than most things on the Earth can, and so these cars and trees will more than likely end up getting warmer throughout the day. But what about at night? In the absence of the sun, the sky essentially acts as an infinite heat sink. There is very little incoming radiation, and so the Earth can emit a huge amount of heat energy back into space in order to cool itself down. The ancient Persians recognized this, and were able to create ice in deserts overnight for centuries. Even today, we might see frozen dew on our lawns early in the morning, despite ambient temperatures being well above freezing. This process, which is known as night sky radiative cooling, is one that underpins the function of our device, Cosmic Ice. Our prototype consists of two main components: the radiator, which cools down a thermal mass overnight, and the chamber, which will contain our food. The radiator was carefully designed in order to maximize the possible heat emission from a pond of water overnight, whilst also ensuring that it could be easily reproduced by the people of Espiritu Santo. The white color of these interior walls increases the emissivity of the radiator, meaning more heat can escape the water towards the sky. During the day, the warmer content of the chamber can then radiate heat towards this cold thermal mass with very little energy return, cooling it down. The chamber is a square prism made entirely out of wood, which was our material of choice due to its decent insulation properties, ease of work, and availability in Vanuatu. It has two internal supports that allow the cold radiator to sit snugly on top. A woven bamboo lid can be placed over the radiator's opening to insulate the cold water from the sun's radiation. Here, we're just using a towel. So we filled the radiator about a fifth of the way up and left it to cool overnight. When observing the temperature before sunrise the next morning, we found it had dropped to about 6 degrees Celsius at an ambient temperature of 14. Then, we left the radiator on top of the chamber for about 5 hours and found the temperature inside the chamber to be about 10 degrees Celsius. Not quite as low as what we were aiming for, but still very promising considering this is our very first prototype. We feel that if we were to find a more open location for the radiator to cool overnight, ideally with less obstructing buildings, then the temperature would be able to drop a little bit closer to our goal of 4 degrees Celsius. Furthermore, lining the inside walls of the chamber with polystyrene would reduce the effect of daytime solar radiation on the internal temperature of the system.